So I wanted to let you know a little bit about why you're taking the courses you're taking when we look at engineering education here at Behrend. And just to kind of break down into a diagram on the courses that you kind of focus on in your 4 years getting an undergraduate degree, you're starting probably with a lot of your math and science courses, your calculus, your physics, your chemistry courses. Those are the foundational courses that you need in order to be able to do the engineering work. After that, you start taking some of your engineering courses. Usually your sophomore year, you start on those into your junior year, and you take a lot of engineering courses in your major to kind of learn all the skills that you're going to need, all the theory, all the analysis techniques. So those are some of your core courses. In your senior year, you'll be given the opportunity to take some elective courses, which are usually from a list of classes, and you have to pick something that interests you that is applied towards your major. Usually they're in your major. Sometimes there's a few of them that might be outside of your major too that relate to engineering. And you also take, along the 4 years, you have to take a number of humanities and social science courses, arts classes, and things like that. Those classes are to help round you out as an individual, to give you some good communication skills, to learn some other things that might be related to life in general. In order to get a university education, we look to have a well-rounded individual in the end. If you look at just technical classes, you could go to a trade school or something like that and get an education rather than a bachelor's degree. But when we're looking at a university education, you're looking for a well-rounded individual that you'll receive all these areas, your background courses, your core courses, and some supporting things. So when you look at the classes you take in your engineering classes, you can break them down into some general categories. A lot of your classes will be your analysis and design classes when you're an engineer, and those are your classes that you're learning theory, you're learning how to apply that theory into different situations, you're trying to make sure that you size things correctly so they don't fail, that you're not using too much power, and meeting all your specs. Those are a lot of your use your math and science in those classes as a background in order to make predictions, in order to design things properly. You also take maybe some computer classes that maybe are applied to that major. It depends on which major you're in and how many different computer classes you might be taking. In like some electrical engineering classes, you might work in some of the computer simulations into the course. In mechanical engineering, we have a lot of CAD and maybe some finite element analysis to do some looking at the stresses in parts. In maybe an industrial engineering major, you might be simulating systems and trying to optimize them. Chemical engineering, you could be making up computer models to control the processes. So there's a lot of different computer classes you might take. Each major has their own skills and their own software that they use. And then there's a lot of laboratory classes, experimental-based classes. You'll run into some of those in your major. You might be setting up simulations and trying to hook up circuits in an electrical class. You might be testing metals in a materials class. So you might be setting up chemical processes in a chemical class, chemical engineering lab. But some hands-on experience to kind of show, does the theory fit what you see in practice? What's the differences between what you predict should happen from the theory that you learned in your design and analysis classes, and how does that apply to the actual laboratory setup when you're testing things, and what are the differences from real life and the theory? And you kind of learn some of those differences in those labs. So you might take a few labs in those areas. So the skills we're trying to let you learn as an engineer, you're trying to figure out, how do things work? Why do things work? So you can make predictions in order to make things better, to optimize things, in order to make sure things don't fail, in order to make things more efficient. You want to be able to have those math skills that are helpful in doing all the analysis. I know you take some calculus classes, and you learn a lot of trig and geometry and algebra. Most of my students do pretty well in their calculus. They tend to mess up in their algebra. So make sure you know those background math courses too. You need to have a good interest in science, chemistry, and physics or biology. Physics is the main background for most of engineering, but depending on the major, you might be involved a little bit more in the chemistry end. We're looking at materials from maybe their electrical properties to their mechanical properties, or maybe developing new materials, the plastics and things like that. You could also be involved in biological science, looking at applications in biomedical engineering. So You want to be able to work with other people. That's going to be important as you've kind of been working on teams. You kind of see that as engineers, you're going to be working on it with a team of people. You have to be able to work with other engineers. You have to work with people outside of engineering in order to make the whole product come together. You have to have good communication skills with those people. You'll have to write reports. When you do some testing or make up a design, you have to be able to report it to the people that need to know what the design is about or what the results mean. So being able to be good, have good written communication skills and good verbal communication skills is important. Good visualization skills are important too, because a lot of times you're coming up with ideas in your head. You have to try to put them down on paper. Sometimes computer tools are used for that, but a lot of times you're just sketching things out by hand in order to relay that information. So being able to think about something, picture it in your mind, and getting it out and communicating that idea to other people is helpful. And you need to be very persistent and hardworking, as you probably have noticed in your education, that probably you're doing a lot more work than maybe some of the people that are in other majors. Engineering tends to be a pretty demanding major, so you'll see you probably have a lot more homework over the time that you'll be here at Barron. So that's just to be expected. And and what I see it is that if you can make it through 4 years of engineering, it shows to an employer that you can learn something, that you're hardworking, that you'll be a good employee. So as an engineer, the things that you will be expected to do, depending on the type of job you get, these will vary on the amount of which of these you might do. But you'll probably be doing some design end of things, some evaluation of existing designs, trying to optimize new designs, coming up with ideas. So it could be some analysis and modeling. It could be testing and diagnosing problems, trying to troubleshoot to figure out why things aren't working right, trying to tweak the system. You could be working on new products and developing from scratch. You could be working in management. A lot of engineers move up into management, or at least they move into project management, where you're overseeing a project and you're in charge of other people and the resources in order to get that project done. My first job, I was involved in some inspection and quality control on our machines. I was in charge of using some high-tech equipment in order to make some measurements that most of the technicians couldn't use that equipment, but we were trying to prove that our machine was putting out products that they were supposed to be. I was working in their R&D lab. You could be involved in sales. Also in my first job, I would go out into the field with a sales representative, but I would maybe answer some of the technical questions that the customer had that the sales person couldn't answer. I was the engineering expert that was on that trip. And you could be working maybe with some support, maybe working with writers. Those are possible things. A lot of times you have to write up reports too, so it could be part of your job. Some people end up doing that more on a full-time basis. And you could be working on codes and standards. There's a lot of industry codes that are written by the engineers that use those codes and standards. So we were working with surface finish when in my first job, and measuring surface finish, and we would go to meetings with other industrial representatives that worked in surface finish, and we were trying to revise the codes and standards that were used in order to measure surface finish. So that's a common practice. And you can be involved in teaching. A lot of engineers maybe some of them their goal is to teach, but some of them maybe just want to teach something on the side as an adjunct faculty somewhere. We hire faculty here that are working in industry, and they do some teaching on the side here. And you can be involved in research. A lot of larger companies will hire engineers to do research for them. You might need advanced degrees for that, but you could maybe even with a bachelor's degree, you can work in some level of research at a smaller company possibly. So those are some job functions you might run into. So what we want you to do is kind of switch from thinking about you and you have a major you're picking out, and somebody you're picking out a location where you want to work, and what job functions am I going to do. These aren't individual things that you're trying to decide on. That we want you to kind of more think of as a whole, that you're picking out a major now, and you're going to be studying that major. That will evolve into learning the job functions, and you'll be learning more job functions when you get on the field, and developing more skills, maybe getting further education in order to develop those skills. And then, where you might work could be a broader scope of that certain engineers are used everywhere, so where you end up could vary. You can look for things around home, you could look for things across the country or across the world. So those are all options that you'll have, hopefully. And as you go through your 4 years, you're kind of focusing on getting through your major, but you'll see that the opportunities will arise as you get near the end in order to look out for those job opportunities. Internships always help to kind of practice and help you be more marketable too. So that's a little bit about your education and what we're trying to provide you with here.